Okay, let's start our class. Yeah. Good evening, students. Am I audible and my screen is visible?
Yes, sir.
Okay, thank you. So in the last class, we were discussing about the switching, right? So that is like selecting an appropriate path for to send the data uh, to the destination, correct? Then we have seen the different switching techniques. The very first one is the circuit switching, then the message switching and packet switching. So these are the three main switching techniques available in the communication network. Then we have seen the in detail about each of them, especially the starting to circuit and the message switching. So in the circuit switching, we have seen like before transmitting any data, for example, in this figure, S source and D is the destination. So they want to make a call, right? So before share the information or before they talk, so there should be a dedicated link establishment between these two, right? So that's the reason the circuit switching is also called the connection oriented uh, switching technique, right? So in this circuit switching we are having three different phases. So the very first one is we have seen the circuit establishment. So this is the one, the circuit. So in this we have two different or three different requests, I mean messages. So the very first one is the request, right? Then once it reaches the destination there will be a reply, right? Then there is a dedicated formation of the route, the red one. Then the second phase one is called the data transfer. So once the uh, dedicated route is established between the source and the destination, then they can start sending the data. And then finally the third one, that is the circuit disconnection. Once the data transmission is done and they don't have any data to transmit between them, then either source or the destination can initiate for disconnecting the circuit, right? Then we have seen the some advantages and the disadvantages. Then we have seen the message switching, right? So in the message switching, this message switching is a connectionless network, means there will be no dedicated path establishment between the source and the destinations, right? So whatever the data the source is having, so they call the message. So message which contains the payload actual data and the header, that is the source and the destination header, right? So depending on that, it will be like source will be sending the data to the destination, right? So we have in detail we have discussed this circuit, correct? M1 is the message 1 and M2 is the message 2, right? And this circle is called the switching device. So switching device, what it does, whenever it receives the data from the source S, right, or the message M1, right, it will check whether is there any errors in it, right? If it is any error, then it will again ask the source to resend it, right? And if everything is fine, then it has to forward it to the desired destinations, right? So for that it will check whether the links are busy or not. If the link is busy, then whatever the message it has received from the source, it will store in its memory or the queue or the buffer for certain time duration, and again it will sense the link, is the link is busy or idle. If it is idle, then it will forward that message to the desired destination. So they use the store and forward technique. That's why the message switching is also called the store and forward technique, right? So this is about the complete the message switching. Then the last one is the packet switching, right? So the packet switching is similar to the message switching, whatever we have seen in this diagram. Same to same only, but there is a difference in this. What is that difference is? Same, whatever the packet switching was called the connectionless network. So this is also connectionless network switching, and whatever the source has created the message, so the same message will be going to the destination D. But the difference is here, so message, right? Yeah. So message will be like this, correct? So this is a message. So in packet switching, what happens, this message will be divided depending upon the data rate of a output link, right? So we call the MTU maximum transmission unit or maximum segment size in the transport layer. So this is the M message M, write it here, message M. So that M is divided into 3 units. The first unit is called the A, and the second unit is called the B, and this third unit called the C. So these units, whatever I'm saying, those are called packets. Clear? So the source, this is the S, that is the source. The source also send a message M to the destination D. So here is the D. Okay. So before sending the information to the switching device, so these are all the switching devices, correct? So before sending to the first nearest switching device, what this source does is it will divide the message into the number of packets depending on the output link. Okay, whatever the data rate they are having. So depending on that, it will be dividing. So once the divide is done, so before sending that one, this whatever packets I am calling message, right? Suppose this is the B, so it what it contains is two things. So the first one is the payload, same whatever we have discussed in the message switching. The first one is the payload, then header will be there, header will be there. The very important one is the sequence numbering. SEQ is the sequence number. So sequence number will be there, and the header information will be there, and the actual data will be there. This is a one packet. Okay. So why the sequence numbering is required, I will tell at the end. Okay. And we know what is the payload and what is the header and all. Correct. Okay. Let's come to this circuit which we have designed for the message switching. So the source is there, and source has divided 3 different packets, that is A, B and C, right? So and it is sending to the switching devices. So when the A comes here, right? So randomly it can select any one of these 3 routes. Either it can choose this route, this route, or this route. So for example, I have chosen this route. Say for example this route, right? So like this it will be reaching. And the second one, for example, it is like this. So it is chooses this path, then this path, then this path, correct? And for example, the C will choose this route. Okay. So in earlier in message switching, what was there, the complete message, whatever the content was there in the message, the complete message M1 will be routed through a particular route. But here the same message will be divided into number of packets. So here I have taken example 3 packets A, B, C. So A will be taking this route and B will be taking this route and C will be taking this route, right? So here at this point, right? Suppose at the first, right? Need this thing, this. So yeah, here at the destination D, we are receiving the first packet has the A. Okay, and the second packet, suppose this is the shortest route, right, compared to the B, whatever it has taken. So the C will be the second packet reception at the D, and the third one is whatever the route it is taking, this route, it's a little delayed version of the A and C routes. So this is the packet I have received from the switching device, right? But the source has sent the packet like ABC and the destination is receiving the packet as a ACB, right? So I need some kind of a parameter which can distinguish this is the first packet, this is the second packet, and C is the third packet, correct? So for that reason I have used the name called the sequence number, SEQ, right? So for example, whenever it creates here, right, ABC is created, for example, sequence number will be given to here 0, right, and here will be 1 and here will be 2. So 0 1 2. So when it reaches here, right, so I'll what I will get, here is the 0, right, and here is the 2 and B will be the 1. Then D, what it does, it will reorder it, right? It will he will keep as it is this, and only this one will be swapped with the B, right? So swapping technique will be used here. So finally I will get the message as it is like this. Then at the finally whatever the thing we have done here, right, this is we call the demuxing, right? So here we'll be doing the same thing but in the reverse direction, right? Just we need to merge them back like this, correct? Finally the node D will be receiving the message which has sent by the source S, right? M was the whatever it is generated, M has the message and the destination is receiving as a message M. That's all, right? Is it clear whatever I have explained to you, students? Am I clear to you?
Yes, sir.
Yes, sir.
Okay, great. So the main advantages here, advantages in the packet switching network is what? Can you tell anyone what will be the advantages here? So there will be no delay or less delay in delivering the packets. So because this switching device, right, doesn't say all the packets to choose the same route, correct? Any route it can choose, right? So there's a less delay in delivering the packets, quicker than the previous one, right? Very important as compared to the message switching is the switching device, whatever the we are having the switching device, these circles we call the switching devices, right? So switching devices doesn't require the massive storage. In earlier, in message switching, we used to store whatever the size of the packet it is. If the link is not free, right? Then if it is free, then we used to forward. That's why they call the store and forward technique in the message switching. But here we are not doing that one. If it has the packet, then just send it. So we are not worrying about the storage and all, right? Good. And it allows the main one is the it allows the simultaneous usage of the same channel by multiple users, right? So one more, so this is the one user, right? Suppose one more user is here, right? And this user is also connected to the connected to the same switching device, okay? And it can use the same routes, this route or this route or this route, so they can use it. So there is a sharing of the bandwidth here, okay? So it ensures the better usage of bandwidth compared to the other, correct? So what will be the disadvantages here? It looks little bit complicated structure, right? So yeah, that's the one disadvantage, right? And the second one is, if packet, suppose the C packet is lost, okay? Suppose C packet is lost, means it has to whatever the switching device has received the if doesn't receive the C, for example D only has not received the C, then D will send a request to the source to resend the packet C. Okay, that's the one of the disadvantages here compared to the other switching techniques. Fine. So these are the three different switching techniques where we will come across in the communication networks. Okay, well and good. Fine. Now we'll start with the new concept called the network topology. Right? So network topology, it's an arrangement of a network, right, which comprises of nodes and the connecting lines are the links via sender and the receiver. Okay, whatever the structure we have seen there earlier, here we have seen this is a one kind of a structure, correct? And this is a one another kind of a structure. Correct. This is another kind of a structure. So these are like a network, right? So this is one kind of a topology we have considered, and this is also one kind of the topology, right? So you can write down network topology is an arrangement of a network of nodes and links via sender and receiver, right? So this network topology NT, what we call in short. So in the network topology, there are four different types. So the first one is mesh topology. The second one is, sorry, the second one is star topology. The fourth one is the bus topology. The fifth one is ring topology. And finally, the last one is, it's a kind of a hybrid. It consists of a sum of these topology. So I call hybrid topology. Okay. So the topology is the structure of a network, how it looks, or the arrangement of the networking devices along with the links. So how they have arranged in a particular or at a particular place. Let's see one by one. The first one we will see the mesh topology. Okay. So a little highlighting I'll do so that it will be visible to everyone. Good. So the first one, mesh topology. So here, so every device in the network is connected to with all the devices in a network, right? For example, you can, okay, I'll take a computer only here. So this is the one, and this is the another device. So this is the third device. Let me arrange in one particular fashion so that it will be easy for me to connect the device. And this is the sixth one device. So in the mesh topology, what will happen is a particular device should connect to all other devices. For example, A is connected to here, and this is connected to here, and sir, and this will be connected to here. You can ignore this arrow mark. Arrow mark, if you ignore, then it will be like, I want to say that in both the direction the communication will be there. So from here to here, and finally from here to here, right? So this device is connected to all other devices. Similarly, this device is connected to the remaining of the all devices, and this is connected here, and this device is connected to here, and finally this one is connected to here. And anyway, this is connected to here, it's already there. Then here you can connect this one to here. Okay, you can take a notes parallelly so that it will be easy for you to understand. And finally here to here, correct? And we can connect these two. Here connection, one more connection is there. The last one is here to here. So this is the complete mesh topologies, right? Every device is connected to the another device via a particular channel, right? So suppose n number of devices are connected with each other, right? Then the total number of dedicated links required to connect them is NC. Yeah, this is like I want to make n n choose C, n choose 2, correct, n choose 2. So which is equal to what? N into n minus 1 divided by 2, correct. So for example here we are having the six nodes, right? So 6 nodes. Suppose I want to calculate the number of dedicated links required for the 6 nodes, right? So it's like a 6C2 equal to how much? 6 into 5 divided by 2. Total 15 links we need. Is it correct? 15 links are there in
Yes,
this?
sir.
Okay, fine. So this is about the mesh topology. So the second one is the star topology. Let me highlight this. The star topology, the name itself it indicates the exactly what it should be. So I'll give a one example here. Suppose this is the hub. So what exactly hub, repeaters, right? Routers, switches, all will see in the maybe next to next class. So the hub in the star topology, it will be like all the devices are connected to a particular device. Here it is a hub in a star manner, right? So the device is connected to here. So in the this is also the both the direction. So better I'll take this one only, and it is connected to here. And finally, this is connected to here, right? So all the devices are connected to a centralized unit. Here we call the hub. This is a centralized unit, hub. Okay. So whatever the data it wants to send, suppose this device wants to send data to here. So there is no connection direct here. So it has to go through this device only, like this. So it has to send to the hub and hub will send to this. And similarly this device wants to send to here, then same procedure it has to follow. It has to send to the the centralized device or the centralized unit. Here it is a hub, then that hub will forward to the desired destination. Okay, so in the here in this what we call the arrangement of the network, right? Here what? So we are having 6 devices here and we need a 15 links. And here how many devices we are having? We are having 4 devices and we need a 4 number of links. So important one is the number of dedicated links equal to number of devices connected to the centralized device. Correct, no? Right? So the advantages here is the first one, we can reduce the number of links, right? And each device requires only one port to connect to the centralized device. So here each device used to require how many? 5. So number of whatever the number of devices are there minus 1 number of links are required for each device. So that many number of ports required in the device, but here we need only one port. It can communicate to each and everyone, right? So disadvantage is here is, so can you tell me what would be the disadvantages in the star topology? Anybody? Dipanjan?
Direct data transfer not possible, sir. If the central hub does not work, then the entire topology will fail.
Yeah, correct. Whatever he mentioned is the correct answer. So the centralized device called the hub, if it doesn't work, then the complete network will shut down. So there will be no communication exists. That's the main one. So okay. The third one is bus topology. So in this topology, every computer and network devices is connected to a single device. Okay, and it transmits the data from one end to the another end in a single device, and there will be no bidirectional feature will be there in the bus topology. For example, so this is the bus topology. This we call, what we call is the coaxial cable. This is a coaxial cable, right? In the bus topology, there will be only one coaxial cable, and the devices will be like this. Suppose this device is there here, and the one more device, right? So these devices will be connected to here. So we call these are the drop lines, right? So each of these devices are connected using the drop lines, right? So like this it will be connected. So these are drop lines. This is drop line, and sorry, and this is the coaxial cable. Okay, so here number of cables is only one, right? And the number of devices are connected to this coaxial cable using the drop lines, right? So here uh, advantage is if n devices are connected to each other in a bus topology, then the number of cables required is only one, right? And the cost of the cable is less as compared to the other topologies, right? But it is used to build only the small networks, maybe a, the lab kind of infrastructure, only there we can use it. But disadvantages here is, suppose something, this cable has broken here at this point, for example here, sorry, so here it has broken, so this part is broken, then these devices cannot communicate with these devices, right? So there is a complete disconnection of the communication here, right? So for seeing the whether the link is available whether the link is free, whether the link is busy, right? So for this we have a certain standard protocols, right? CSMA, CD, pure aloha, slotted aloha. So all this will be there. And another disadvantage here is we can, during the heavy traffic, right? So suppose this device is also having the huge data, and this device is also having the huge number of data, this and as well as this. So at that time there will be the traffic congestion. As a result, the data might lose here, right? To avoid that, we need have some other protocols to support this kind of situations. This is about the bus topology. So the fourth one is, so in the ring topology, the ring topology, it's a completely closed loop. So like this, the what are the circle or what you call the ring. So the name has come because the devices are connected in the fashion of the ring, right? So all devices are connected to one another in this shape, or you can call the closed loop form, so that each device is connected directly to two other devices. For example, so like from here, so the one device is here, so it's the second device is here, the third device, and this is the fourth device. Okay, and these devices are connected here. Yes, and this device is connected here, and finally this device is connected here, right? So this device is connected directly to this device and this device, correct? And this device directly connected to here as well as here, but these two devices are not connected with each other, and these two devices are not connected directly with each other, right? So we need so this is the one network, and they always wants to communicate with each other. Suppose these two are there, then direct communication will be there. From here it is connected, and here it is also connected, they can communicate with each other. But these two wants to communicate, or these two wants to come, so what to do there? So here they have come up with an idea called the coin, or they say the token. For example, this is a one token. So this is a very big one. Let me try this. Yeah, this is, they have come up with one idea called the token ring. This is the one token, right? This is a token. So what this token does is, this token will be initiated by a master node, right, or master station or controller in this topology. For example, this is the master node. Suppose this is the master node, and this has some information need to be communicated to here. So this is the token, and this token will be circulated in this fashion, like this, like this, and finally like this will be circulated. So whenever this token comes at this point, only this node or the device can send. Suppose this node is there here, right? Then none of the devices will be transmitting any information, and this whenever it comes here, then only this device can send the information. For whatever the period of time this device will be waiting here, till that time this device can send the information. Then it will take that information and it will move to the next node. Whenever it comes here, only this node can send the information. And when it goes here, only this node can receive the information. Right? Suppose this node doesn't have any information, right? Then till then also this token has to come here and wait. So there is like a, we are wasting unnecessary bandwidth here, and the time also we are wasting, right? So this is not a good idea to use, right? So this is about the complete ring topology. And the one more disadvantage is here is, suppose I want to add one more station. For example, I want to add this, right? If I want to add this one, means where to add. For example, if I want to add means I have to disconnect all, right? So that is the disadvantage. Or for the troubleshooting for anyone, then I need to disconnect each and every station or the node in this network. So that is the disadvantages of here, right? But very or advantages of this topology is, we can avoid the collision here. Whenever this node has the data, then only it has to data, and it has to send the data when this token arrives at this place, and this node cannot transmit when the token is not there here. So that is the one. So in general, what we can say, that there is a equal access of the bandwidth for all the users, and it's very cheap to install, and we can expand also this. So it's very cheap. So this is how the ring topology works, and its advantages and the disadvantages. Is it clear?
Sir, the token is used for sending the info or receiving the info.
Both, both. So whenever it
Okay.
is there here, it will receive data, will be there here. Then that data will be taken. So for example, the master node wants to send to the device here, whatever the information it is there. So when it comes here, so this is not there, this is not there, so it has sent the data, and when it is here, then it will deliver the whatever the data it is. And suppose this wants to respond to this guy, then again it will send the information, it will store here, right? And it will move back here, right? And when it comes here, and it will dispatch the data, whatever the data it has sent. So like this it will work. Clear?
So the token is bearing the address, right? The
Yes,
sender
sir.
and the receiver. Okay,
Yes,
okay.
yes,
Thank you,
yes.
sir.
Yeah. Okay, fine. The last one is the hybrid one. Hybrid topology. So here, so there will be bus topology, for example, like this. So bus topology will be there like this, and suppose the mesh topology also we can create it here. So like this, like this. So this is the mesh topology, correct? And if you connect here, so this is mesh, this is a bus, right? And we can create one more star also here, suppose. Ignore the arrow direction, arrow mark. Right, so this is mesh topology, this is bus topology, this is star topology. Right, so like this, if you want to use the advantages of the mesh topology, advantages of bus topology, star, or you can if you want the ring topology also, you can use the ring as well. Yeah, we can create that one and use it, right? Wherever we need the advantages, right, there we can use the hybrid topology. Okay, is it fine? Anyone has a doubts regarding the topology?
No, sir.
No, sir.
Okay. Okay, thank you. So, yeah, this is what today I wanted to discuss.